At the top of a mountain in the Swiss Alps lies a facility housing a laser powerful enough to split the sky. Here, scientists are testing laser-guided lightning. In 2023, scientists at Tissot Lightning Research Facility published a paper straight out of science fiction, laser-guided lightning. But to understand laser-guided lightning, we first must ask, what is lightning? Lightning is like a massive electric spark in the sky caused by a separation of positive and negatively charged particles that want to attract. Why this happens isn't fully understood, but we do have good theories. For a cloud to become electrified, you need three things: supercooled water droplets, tiny ice crystals, and graupel. Graupel is a pellet of soft hail created when water droplets freeze to ice crystals in a process called riming. When ice crystals collide with graupel in a cloud, depending on altitude, temperature, and humidity, negative charge flows to the graupel while positive charge goes to the crystals. These crystals get carried to the top of the cloud in an updraft, while the heavier graupel gets left at the bottom. This leads to polarization, with positive charge in the top half and negative charge in the bottom half, with a layer of positive charge again at the very bottom. When this process is extreme enough, we get lightning. A lot of this lightning stays within the clouds, but some reach the ground. Cloud-to-ground lightning starts with a downward traveling stepped leader of negative charge, which attaches to the earth and rebounds with a powerful return stroke we see as lightning, superheating the air and giving us thunder. Lightning strikes pose a threat to modern infrastructure as power utilities and especially computers are very vulnerable. Things like airplanes, satellites, and communication systems are all at risk. So, to protect these things, we have to strike lightning before it strikes us. We must electrify the sky. That brings us back to our original study. At the Tissot Lightning Research Facility in Switzerland, researchers shot extremely short and powerful laser pulses into a storm cloud, passing near the tip of a 124-meter tall telecom tower. Energetic enough to ionize the air, this laser strips electrons from air molecules, leaving a long tube of plasma rising into the sky in a process called filamentation. Because the air is ionized, the inside of the plasma filament has a higher density of free electrons. Therefore, when the laser is pulsed into the sky, lightning is discharged and follows the path of these electrons, of least resistance, the telecom tower. The Earth's return stroke leaves us with a flash of lightning rising from the top of this tower. This study is the first to experimentally confirm the possibility of laser-guided lightning discharges, a breakthrough in lightning research, paving the way for new research on applications of lasers in atmospheric science and protecting important infrastructure. This technology has great benefits for humanity, but can it represent the nature of humanity itself? Humans have split the sky and harnessed the power of lightning, domesticated thunder, tamed nature itself. We can control the very thing that gave our ancestors fire, civilization. Lightning suppression belongs to a broader category of weather modification research, along practices like cloud seeding. If it's in our nature as humans to conquer, how can we help ourselves from looking to the sky? And what consequences are we overlooking? As technology advances, who sees those benefits? By doing this research, will we only end up with widening social divides? Who gets to feel rain during drought? And who must get struck by lightning during a storm? Our ancestors worshipped the sky, yet today we guide it into our own hands. Are humans meant to play God, or are we merely riding our own lightning into demise?